Before we start to learn about logic gates, first let us know why do we need them, as after all these gates function like switches, so why do we need make simple thing complex? Don't worry, we are not going to study cars. Imagine a scenario, where, your angry boss asks you to automate car headlight using light switch and a darkness sensor. Further twist is he need two modes. First mode, where he demands that, lights should be on, only if there is dark and the switch is put on as well. Here we can use, AND gate. AND gate ensures that output is not high, till both the inputs are high. Which means headlights will remain off unless both the dark sensor and switch are activated. In image 1. Lights are off as dark sensor is also off during daytime and switch is also off. In image 2, dark sensor is on as it's night but switch is off, so lights remain off. In image 3. Switch is on but dark sensor is off due to daytime. So lights again remain off. But in image 4, since dark sensor is also on during night and switch is also on, so headlights get switched on as, AND gate is being used. Second mode, now boss demands that, lights should be on, if there is dark, or if the switch is put on, or if both there is dark and switch is on. Here we can use, OR gate. OR gate ensures that output is high, when either or both the inputs are high. Which means headlights will remain off only if both the dark sensor and switch are not active, else lights will be on. In image 1. Lights are off as dark sensor is also off during daytime and switch is also off. In image 2, dark sensor is on as it's night but switch is off, still lights are on. In image 3, switch is on but dark sensor is off due to daytime. Again lights go on. In image 4, since dark sensor is also on during night and switch is also on, so headlights get switched on. So now, since we have an idea about applications, so let's dive into logic gates.
What is a logic gate? A logic gate is a device that acts as a building block for digital circuits. They perform basic logical functions that are fundamental to digital circuits. Most electronic devices we use today will have some form of logic gates in them. In a circuit, logic gates work based on a combination of digital signals coming from its inputs. Most logic gates have two inputs and one output, and they are based on Boolean algebra. At any given moment, every terminal is in one of the two binary conditions, true or false. False represents 0, or low, and true represents 1, or high. Depending on the type of logic gate being used and the combination of inputs, the binary output will differ. Today, we will visualize this whole concept, using Arduino, and we'll also learn how to make this project. In this video, yellow switch is used to change the gate type. Red and green switches, represented by A and B, are inputs, attached to small green LED to indicate high and low states of switch. Output is denoted by Q in form of red LED, off LED indicates 0 or low, whereas glowing LED indicates 1 or high. Gate name and states are also displayed on LCD display. This is AND gate. Here output is high only if both inputs are high. This is OR gate. Here output is high, when either, or both inputs are high. This is NAND gate. It is reverse of AND gate. Here output is low, when both inputs are high, else the output remains high. This is NOR gate. It is reverse of OR gate. Here output is low, when either or both inputs are high, else the output remains high, if both inputs are low. This is special purpose, XOR gate. In this, output is low, if both inputs are either high or low. And if one of the input is high and other is low, then the output goes high. This is special purpose, XNOR gate. This is reverse of XOR gate. In this, output is high, if both inputs are either high or low. And if one of the input is high and other is low, then the output goes low. This is NOT gate. This is simple, single input gate. Here output is low, when input is high, or vice versa. This is YES gate. This is simple, single input gate. Here output is high, when input is high, and output is low, if input is low.
This is the circuit diagram. Download link for program file is given in video description.
Please do like, share, subscribe the channel, and press the bell icon, so that no video is missed.